Alright, this LeetCode question is called remove linked list elements. It says remove all elements from a linked list of integers that have value val. So the first example is a linked list 1, 2, 6, 3, 4, 5, 6, and val is 6. So the output is that linked list with any element with a value of 6 removed. So what we have at the end is 1, 2, 3, 4, 5. Alright, so you might think that the way to solve this is to check the node you're currently on, and if it doesn't equal the value, you move the pointer to the next node, and if it does equal the value, then you can just reassign it. So let's see how that would work. I've denoted the current node to be C, so let's just see how this works. So we're on the number 1, that doesn't equal the value 6, so we move it. We're on 1 again, doesn't equal the value 6, so we move it. Now we're on the number 6, which does equal val. How would we remove the node that we're currently on? We don't have access anymore to the node behind us, so what do we do now? We're kind of stuck. This isn't an impossible hurdle to overcome, it would just be really difficult. So instead of checking the node we're currently on, what we should do instead is to check the next node. Alright, let's see how that works. So we're on the number 1, we check if the next node is equal to the value. So is 1 equal to 6? No, it's not. So then we just move this up. Now we're on the next number 1. We check its next value, which does equal to 6. So since it does, we can just reassign the next pointer to the node after it instead. So this looks okay, but what happens if the first node in the entire linked list equals the value? So what if it looked like this? Well, if we're only checking the next node, we'd be ignoring the fact that the node we're on actually needs to be removed also. This brings us back to the problem that we originally faced, which is what happens when the node that we're currently on is the node that needs to be removed. So to ensure that the next node can always be checked, we should create a dummy node and put that at the beginning of the linked list. Alright, so now we've added a node at the beginning of the linked list and given it some kind of value. We'll just put -1 in this case. So doing this ensures that we check every node in the original linked list, because when we check current node's next value, that would be what the original head was. Alright, and remember the original head was here, but for all we know, this head could end up equaling the value that needs to be removed. So now we'll just reassign head to also start where this dummy node is. Alright, and I'll just change this back to what it originally was. Alright, so let's start. We'll check to see if the value of the next node equals the value of the node that we need to remove. The next value is 1, so we can just reassign current node to that. What's the next value now? The next value is another 1. That doesn't equal the value that needs to be removed, so we'll just move it up 1. Now what's the next value? The next value is 6. So now we need to reassign the next property to be next dot next. So we skip over what was previously the next node. So now that we've done that, we can reassign current to what's now current dot next. Alright, so we do the same thing again. What's the next value? The next value is 3, so we can reassign it. Now what's the next value? The next value is 6, so we now have to reassign our current next value to next dot next. Remember, that looks like this. Okay, so now that we've done that, let's try to reassign current to what's now current dot next. Now we're back in the situation that we don't want to be in. The node we're on is a node that has to be removed because the value of it equals val. So that can't work. Let's put it back to where it was. So all this tells us is that we can't always reassign current to current.next after every iteration. We only do it when our .next property doesn't equal val. Our .next property right now does equal val, so we just hold off a minute and go to the next loop. We do the same check. Does our .next property equal val? Yes, it does. So now we reassign it to what is next, which is this 6 right here, .next, which would be null. All right, so now our current node's next property equals null. So now we break out of the loop and we stop iterating over the linked list. Now we can just return our linked list. But now we run into one final minor problem. If we returned head, which is this, head is pointing to the dummy node that we added at the very beginning. We don't want that because that was never in the original linked list. What we really want to return isn't head, it's really head.next. So when you return head.next, that will give you a final linked list of 1, 1, 2, 3, and then null. All right, let's get to the code. What LeetCode has given us is a function called removeElements, which accepts a parameter head, and head just represents the entire linked list, and a parameter val, which represents the value of any node that we want to remove. So the first thing we should do is we should just check whether or not head is null, and if head is null, we'll just return immediately. So we'll say if head is null, that means there is no linked list, so we'll just return null. All right, so as we said before, the next thing we need to do is create a new head at the beginning of this linked list, and we're doing this just to ensure that we're going to check every node in our current linked list. All right, so we'll say let current node equal a new list node, and we'll give it any value, but in this case we'll give it a value of -1. So that will look like this. Then we'll say current node dot next equals head. That would just connect it to our current linked list. So right now this is current. And now we'll just reset the head to be where the current node is. We do this so at the very end we can just return head.next. So that'll look like this. That's head equals current node. All right, now we need a while loop to iterate over every node. So we'll say, well, current node dot next doesn't equal null, because we know that if the next node is null, that means we've gotten to the end of the linked list. So now we just need to check whether the next node has the same value as the value of the node that we want to remove. So that's if current node dot next dot val equals val. And what do we do in that case? We have to change our next property to be next.next, which means we're skipping over that node. So current node dot next equals current node dot next. If we look to the left, does current node dot next, which is 1, equal val? All right, just so we can walk through this, let's say val equals 6. All right, so the while loop says, well, current node.next doesn't equal null. Does it equal null? No, it doesn't. It's the number 1. So it goes to line 23 and checks whether the value of it equals val. Well, the value of it is 1. That doesn't equal val. So we need an else statement. And in that else statement, we'll just reassign current node to be whatever current node dot next currently is. So that would be current node equals current node dot next. Then it checks again. Is the next value null? No, it's not. Does the next value equal val? No, it doesn't. So we'll just reassign it again. Next loop, does next equal null? No, it doesn't. But does next equal val? Yes, it does. So like we're saying on line 24, we'll reassign current node dot next to be current node dot next dot next. All right, so notice that current is still on the node with a value of 3. So next while loop starts, does its next value equal null? No, it doesn't. It equals 4 because that's what we just reassigned it to. Does its next value equal val? No, it doesn't. So then on line 26, we'll just reassign current node to be whatever its next property is. So current node will now be the number 4. All right, line 22 asks if current node.next is null, and yes it is, meaning we've come to the end of the linked list. So all there's left to do now is to return not head, remember, but head.next, because head.next represents what head used to be. All right, so let's run the code, see how we did. Looks good, let's submit. All right, so as you can see, our code was faster than about 76% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. It helps out a lot. See you next time.